Hey everyone, so today we're gonna talk about Pig. So, what is Pig? Well, Pig is an open source high level data flow system. It provides a simple language for queries and data manipulation, which is known as Pig Latin, that is compiled into MapReduce jobs that are run on Hadoop. So, why is it important? Well, companies like Yahoo, Google, and Microsoft, etc., are collecting enormous data sets in the form of clickstreams, search logs, and web crawls. Some form of ad hoc processing and analysis of all of this information is required. So, what is the need of Pig? Well, do you know Java? Some people say, what? Well, 10 lines of Pig is equal to 200 lines of Java. So, why Pig? Well, the first and the most basic thing is that Java is not required. Secondly, it can take any form of data, such as structured data, semi-structured data, or unstructured data. It is easy to learn, easy to write, and easy to read. It is similar to SQL. It reads like a series of steps. It is highly extensible by user-defined functions such as from Java, Python, JavaScript, or Ruby. It provides common data operation filters such as joins, orderings, etc. And it is an ad hoc way of creating and executing MapReduce jobs on very large data sets. It is an open source platform and it is actively supported by a huge community of developers. So why should one go for Pig when there's already MapReduce? Well, MapReduce is a powerful model for parallelism. It is based on a rigid procedural structure. It provides a good opportunity parallelism algorithm. Well, for Pig, it is desirable to have a higher level declarative language. It is similar to SQL query where the user specifies the what and leaves the how to the underlying processing engine. Well, just to give a performance data, let's say there's 170 lines of code for a program in Hadoop. It would just take like 10 lines of code in Pig for the same program. Over the other side, let's say the development time for a program in Hadoop is 260 minutes. It would roughly be half an hour in Pig for the same program. So how Yahoo uses Pig? Well, Pig is best suited for the data factory. The data factory contains pipelines. The pipelines bring log from Yahoo's web servers. These logs undergo a cleaning step where bots, company internal views, and clicks are removed. Researchers want to quickly write a script to test a theory. Pig integration with streaming makes it easy for researchers to take a Perl or Python script and run it against a huge data set. So what does a Pig basic program script look like? Well, there's a script. A Pig can run a script file that contains Pig commands. Then there's grunt. Grunt is an interactive shell for running Pig commands. It is also possible to run Pig script from within grunt using run and execute. Embedded can run Pig programs from Java, much like you can use JDBC to run SQL programs from Java. Well, this is how conceptual data flow of Pig looks like. There are two kinds of flow. The first load is the visits, which has the username, the URL, and the timestamp. The other is the load, which is the pages. It will have the URL and the page rank. So Pig would join the URLs. It would group them by the usernames. It would then compute the average page rank and then filter them according to the page rank. So Pig built-in functions. Well, Pig comes with a set of built-in functions and categorized according to input arguments to the function. Well, there are evaluate functions, load store functions, math functions, string functions, datetime functions, tuple, bag, map functions. Well, the main difference between built-in functions and Pig's user-defined function is that built-in functions don't need to be registered because Pig already knows where they are. Built-in functions don't need to be qualified when they are used because Pig knows where to find them. These are some Pig built-in functions that you can look at and pause the video here. These are some relational operators. Let me give you a demo on a healthcare dataset. So the problem statement here is to de-identify the personal health information. Well, the challenges that we face is that there's a huge amount of data that flows into the systems daily, and there are multiple data sources that we need to aggregate the data from. Well, secondly, crunching this huge data and de-identifying it in a traditional way is the biggest problem that we have. So here we take the database and dump it into a comma separated value format and ingest it into the Hadoop file system. Then the Pig script is run in the Hadoop file system, which reads the CSV file and then de-identifies the columns based on configurations and store the data back into the CSV file. This de-identified CSV file is then stored back into the Hadoop file system. So just to give you an idea of what a Pig's program would look like, well, this is how it will look like in Java though. So here you have the de-identifying program. So this entire thing would de-identify, and then at the last, this here, it would return the entire data, and at the last point we would have the cipher which would just encrypt the file. So here we go guys, that's Pig. Thank you so much for watching.